To build a successful machine learning product, you need to understand how to manage a machine learning project. This takes a lot of soft skills from product discovery, passing by the project planning, and finally the execution. There's a lot more to building a machine learning solution than just knowing some algorithms. Let's get into. The first aspect of a machine learning project that is often forgotten is a product discovery. Basically, what is the size of your market and for what machine learning solution? Like any business endeavor, building new software requires a deep understanding of your customers' problems and how likely those problems are to be addressed by a machine learning solution. This understanding of the problem is critical to estimating the potential monetary gain that such a new product or feature is likely to generate if implemented. It is also important to ideate if there is a feasible ML method that is likely to solve the established problem. This step is typically done as a collaboration between a technical lead and a product manager. Once you have a good understanding of the problem you want to solve, the next step is to assess the data infrastructure. This step will really define the complexity of the project. It is critical to assess the quality of the data and the data infrastructure as soon as possible. This step will heavily influence the cost of the project or even its feasibility. The faster this assessment is done, the faster engineering work can be planned accordingly. This step is typically performed as a collaboration between a technical lead and the data engineering team. Understand that as a technical lead, you don't need to know everything about data infrastructure, but you need to have a minimum level of understanding to make sure that you can lead the project. In machine learning, like any software development, it is important to work in stages. This helps reducing the risk. Machine learning projects can be broken down into 3 stages. The minimum viable product, MVP, where we have a fast development cycle, everything is low cost, but the performance will be low. This is really to assess the viability of the project. Typically, this is done with 1 or 2 people so that we can minimize the cost. After we prove that the project is viable, then we can enter the growth stage. We can invest more money such that we get better returns. This is to establish the foundations of a successful product. We will have more people working on the project. Once we have built the foundations for that product, and if that product is generating revenue, then we can enter the maturity stage. Then more people get involved in the project, it costs more money, and the gains that we get from the growth stage are more marginal. This is to squeeze as much gain as possible from the project. Understand that as a MVP stage, everything has to be pretty simple. We're going to use simpler models, easier to deploy, and we're not going to invest too much time in improving the product. At the growth stage, everything gets more complicated. But usually, we use well-understood machine learning at that stage, meaning that we are not trying to implement the latest advancement in machine learning. We're just trying to use what is known to work at a larger scale. The maturity stage is a moment where more research and development can be done. It is when you can invest more time in investigating if the latest advancement in machine learning could help you get more gains when it comes to your product. So it is important to move from simple to complex in stages. The investment in each stage and the prioritization should be motivated by the previous stage's success. And also you need to factor in that at the MVP stage, this may require more time to discover the data. In machine learning, there may be a lot of different projects that you may be working on, and it is important to prioritize the right project. What you want to be thinking about is to maximize the gains and minimize the cost. You want to work on the low-hanging fruits while making sure you get a lot of rewards out of it. Not all machine learning projects are created equal. It is important to utilize the product discovery and the infrastructure assessment step to estimate the potential gains and costs. We need to optimize for high gains and low cost complexity. It is very easy to lose yourself and work on some projects that have no impact on the business. So it is very important to prioritize your work. To maximize impact, think if your project is well solved by a machine learning solution. This is not always the case. We always want to apply machine learning, but it's not always the case that machine learning is going to solve the problem that is there. You need to make sure you can tie down your solution to business metrics. So you need to be able to measure that what you implement will have an impact on the business metrics, on the revenue, on the user utility, etc. So it is very important to be able to tie down what you're working on with some important business metrics. This is the way you measure impact in a business. When it comes to minimizing cost, complexity will add to the cost. So if you need to implement a very complex data infrastructure that you don't have already, then this is going to cost a lot of money. Is the reward worth the cost? When it comes to the complexity, you need to understand also how many people you will need to have this project successful. If you need to hire 10 new people to implement this solution, then you need to think carefully if the cost is worth the reward. The data costs money. Machine learning is fueled by data. So you may need to buy some data to a third-party provider, or you may need to build the pipelines to get the right data to your machine learning models. If you don't have the right data, you won't have the right solution. So you need to think about what will it cost when it comes to money and time to implement the pipelines or to buy the data to fuel your machine learning models when it comes to training, but also when it comes to serving your models. And you also need to think about what is the cost of a ML error. Machine learning models, they make errors. It is okay for some products like ChatGPT, where you ask a question and you get an answer that may be wrong. But if you implement some machine learning solution in a healthcare context, for example, where the error can cost a life, then this is something to take into account. So at this point, we understood the product that we need to build. We understood the complexity of the project, and we chose the right project based on gain and cost. So now comes the time to architect the solution. So we have some business requirements, and we need to translate those into technical requirements. A typical business requirement is, for example, how many inference requests per day or per second you need, how many users you will have per day, what minimum predictive performance you need to actually make it a viable product, what is the acceptable latency of your product, etc. So those are business requirements that got acquired by, let's say, your product managers. And this needs to be translated into technical requirements. How do you fulfill those business requirements with a technical solution? Well, when it comes to machine learning, there's a couple of questions that you will need to answer. For example, do you need batch or do you need real time? How many servers will you need? Do you need a fallback mechanism if something is broken? Do we need databases or queues to store the resulting data? All of those questions need to be answered to make sure that we can build a solution and to distribute the work to the right people. This work is usually done in collaboration between a technical lead and a product manager. Architecting the solution is really what is machine learning system design. So this is a small part of that lecture here, but this is one of the most important aspects of it. Alongside design, we need to plan. First, we need to have a strategic planning. This is to set up the long-term vision of the project. We need to establish success metrics. Those are the North Star goals. What will you need to achieve to make sure that you can call the project successful? In a company, it is very important to measure the impact of your project because this will decide if you get a budget for the next quarter. Once you establish the success metrics, then you can measure how much your project is performing. You need to establish milestones. What are the different mandatory steps that you will need to achieve to reach the North Star goals? So this is to make sure that along the way, you provide some proofs and some results to showcase that your project is going forward. You need to be able to establish timelines. You need to make sure that those steps are feasible in a finite amount of time. You need to optimize for time to market. It is very important to show to your leaders that you're able to deliver a product in a finite amount of time. The longer you wait, the higher will be the chances that your team get laid off because they were not able to deliver some impact on the business. Make sure that you establish timelines to make sure that you can deliver a product in a reasonable amount of time. You will need to understand how many people will have to work on the project to have a successful project. How many people and skills do you need to succeed in those steps? Because you need to make sure that those people are available, or you need to make sure that you can factor in the budget those people. You need to establish the required resources. What tool do you need to succeed? Will you need some servers? Will you need databases? Will you need some new machines? Do you need some specific software for you to succeed? So you need to understand what resources you will need to make sure you can succeed. All of that is to make sure that you can establish a budget. By understanding the time, the number of people, and the tools that you require to get a successful project will allow you to establish a budget for this project. Machine learning projects are costly, and it is important to know in advance how much this will cost. And you will need to work closely with multiple teams and leaders in charge of the budget to make sure that you can get that step correctly. Another aspect of planning is tactical planning. With strategic planning, we were looking at the long term. We were establishing what we will need to succeed in the long term. With tactical planning, we need to understand how we do things on a daily basis. How do we actually execute? This is where agile development strategies can be useful, for example. So you will need to answer many different questions on a daily basis. When does the model need to be developed and by whom? When do the data pipelines need to be built and by whom? When does the model need to be deployed and by whom? So how do we coordinate all the different people across teams so the project moves smoothly without delays? This work is typically done with people from different engineering teams and skill sets. And the work of the tech lead is to coordinate all those different people on a daily basis. This requires high communication skills. Something that takes a long time to be implemented is a data pipeline. The data is the fuel of your machine learning project. So this needs to be done before you deploy your models. And often this needs to be done before you start even training your models. As a tech lead, you don't need to know everything about data engineering, but you need to have a minimum amount of knowledge in the subject to make sure that you can efficiently manage the project. Because we have assessed the data infrastructure already, we can mandate the required work on the data side. So we have some data. Do we need to buy more data? Do we need to implement a feature store? How will you pipe the data in your training environment? How will you pipe the data into your deployment environment? Do you need to follow data protection regulations? What data pipelines do you need to monitor when it comes to your data and your model in production? This work is typically done with the data engineering team. You need to think about your training pipeline. One mistake that a lot of data scientists or machine learning engineers do is to train a model in a Jupyter notebook. Training a model has to be treated like any software development, and we need to make sure that we implement the best practices when it comes to training a model. In this era of automation, we need to ensure that the model can be retrained or fine-tuned at will or on a schedule with a high level of control and then productionized at a simple click of a button. Of course, this level of automation is highly dependent on the current stage of project development. Is it MVP, is it growth, or is it maturity stage? However, at any stage, the training pipeline and the production pipeline should be highly coupled and developed by the same people or by people working closely together. So let's look at the potential training pipeline. Let's imagine that a machine learning engineer wants to test a new idea. He may want to modify some code by implementing a new feature or a new transformation. Then he will need to train a model, and we need to validate the model. This is what we can call the experiment sandbox. Everything is done fast, it's immature when it comes to the software, but we can quickly evaluate if a new idea is worth implementing. If that new idea is worth implementing, then the result of that experiment sandbox is to be able to generate a new version of the code base. So we need to quickly be able to change the code base. And this code base will be pushed into a repository like GitHub, for example. So when this new idea is translated into code, we need to make sure that we have some unit tests to ensure that what we push to the code base is not breaking what we have already. With this new code base, we should be able to retrain the model at will with different types of data. Everything should be quite automated when it comes to training. So we should have some data validation. Once the data is validated, the model should be retrained, and we should be able to automatically validate the quality of the model. Those steps should rarely be manual. So this is a training pipeline. As much as possible, we should make sure that those steps are not done manually by somebody. Once we have a new trained model, we need to make sure that we can push it to a model registry. So we need to be able to store that model. Usually it is important to have some integration tests to ensure that the new model is not breaking anything. So what I'm showing here appears to be very automated and very mature. But at any of the development stage, we should make sure that we have modules that capture the different aspects of those pipelines. The production pipeline is what actually provides value to your users. The production pipeline is an extension of the training pipeline, and it is driven by the business use case. How do you actually expose the model to your users? Do you need to build an API for accessing the data? What level of security do you require? Do you need a post-processing module to make the model inference useful? This work is usually done in collaboration with machine learning engineers, MLOps engineers, backend engineers, front-end engineers, and depending on how the model is deployed, sometimes mobile engineers. This is actually one of the most important aspects of your development. It is important to understand how you will deploy before you even understand how you will train your models. So let's say you have your model in your model registry and you need to pull it to deploy it. One of the first things you may want to do is a canary deployment. This is just to make sure that if you deploy it, it's not breaking anything. So this is just to test that the deployment infrastructure is working. Then you need to perform some A/B testing. Usually when you train a model, you assess the performance of your model on historical data. This is not true production data. And what you observe in offline experiments may not work in online experiments. So it is very important to assess your model on production data. Once you perform some A/B testing experiment, you need to ensure that those experiments validate that the model is ready to be deployed. This is a deployment pipeline. So there's a lot of steps you need to go through before you can have your model in production. And then once you validated your model in production, you can release it and you can have it serve your users. It is critical to test in production. Whatever results you get in online experiments will trump everything you've done on historical data. So it is very important to correctly define your online metrics when you design your online experiments. Machine learning solutions have different requirements when it comes to monitoring in production. So you need to be able to monitor if your model becomes bad. In production, everything can happen. You can have some data or you can have some concept shift in your data. The servers can break. The software can have some undetected bugs. You need to monitor those different components and implement plans of action, automated or not, as fallback mechanisms in case something goes wrong. This work is typically done in collaboration with MLOps engineers. So for example, imagine that your users are requesting a prediction from your model. So the router is routing the request to the machine learning model in production, but suddenly we detect some problems related to the model. Fortunately, we have a monitoring system that will enable the request rerouting. This may prevent the bad user experience, and the prediction may be routed, let's say, to another model. And the users, they get the prediction even if the machine learning model in production broke. So it is very important to monitor the different aspects related to the machine learning solution. So one of the most important steps that nobody likes is documenting your work. Along with writing unit tests, this part of the work might be the most underrated effort that contributes to the success of a project in the long run. So you may want to document what you've done in a wiki, for example. You need to document your code and the APIs that you may have created. And you may want to educate your team members by having some meetings or some code reviews to make sure that everybody knows what's happening. Documenting is very important because 5 years from now, you may not be part of the company, and people need to understand quickly how things are being developed and deployed. So they need to have some documentations to refer to when it comes to knowing how things are being done. Something that is very specific to machine learning is the iterative process. If more improvements make sense financially, then you are just getting started. The field is moving so fast that by the time you are done with one iteration, you likely have new tools and techniques that you haven't had the time to test nor implement yet. You may need to invest in the next stage of development or simply update the current one. So this is an infinite cycle that gets machine learning engineers to go to sleep here. So this gives you a framework to make sure that you can manage machine learning projects when you are implementing machine learning solutions. Obviously, everything that we talked about will need to be adapted to your specific needs when it comes to the specific projects that you may be working on. So good luck implementing your next machine learning solution.